we're going to do a little reminder of the distributive property. So I'm going to start by multiplying 2 times 7, and I'm going to use my algebra tiles to do that. So that's really telling me that I need 2 groups of 7. So I'm going to put these 2 space counters here so that I know that that's how many groups I need, and that's going to be sort of my line. And then I can put my 2 counters, or my 7 counters across, and that's how many in each group. So 1, 2, 3, 4, 5, 6, 7, and hopefully that will work. So this is a reminder that I need groups of size 7, and so that gives me the dimensions that I'm going to build my rectangle, right? So my rectangle is going to have a length of 2 and a width of 7, so I'm going to fill those out. Okay, so I have then represented 2 groups of length 7. There's one 7, there's another 7. If I count them, 2, 4, 6, 8, 10, 12, 14, I get the answer 14. So 2 times 7 is 14. So I've transferred the image of 2 times 7 so that I have 2 groups of 7 equals to 14. And I'm now using it with the virtual manipulatives where I have my counters here. Here's my saying I need 2 groups, here's 7, and the area of the rectangle then becomes 14. So I am going to use this setup in order to answer the question 2 times 5 plus 2. Notice the 5 plus 2 is in brackets. So if we were just simplifying this, then we would probably add the 5 plus 2 first and then multiply. But what we're looking for here is a pattern or a rule that we can use with when we're doing the distributive property. So I happen to know that 5 plus 2 is 7, so I've already got this representation set up, but what I'm going to do is I'm going to take these groups of 2 and sort of separate them out. So I'm actually seeing then that the answer, of course, the total area underneath in my grid is still 14, but it's 14 because I had 2 groups of 5 and I had 2 groups of 2. So it's like I'm distributing the 2 to multiply the 5 as well as the 2 to multiply the other 2. So I have here a total of 10 area and here a total of 4 area, and if I add both of these areas together then I get the resulting area of 14, which is what I expected because in the simplified version it's 2 times 7, which is in fact 14. Right, so we remember then that that's how the distributive property works, but in order to actually write down the distributive property I would expand. So let's write expand. I would expand 2 times 5 plus 2 to look like 2 multiplying 5 and 2 multiplying 2. And those are represented then in this one is multiplying over here and this one is represented in that area, and if I add those 2 areas together I still get the result of 14. Okay, so what does that mean when we're multiplying with a variable? Well, I can use the expansion property again, and since this is 2 times the value of x plus 2, I'm going to pull out my multiplication grid, and I have some constants, 2 and 2, so I'll need my 1's, and I also have some x's, so I'll need to get the x's. So I've set this up so that I have 2 groups of x plus 2, so it's saying use 2 groups here of x plus 2. So now I'll just clone these to make 1, 2 groups. So I can see that if I expand this out of the bracket, the area that I will be left with is 2x plus 4, because there's 4 constants. And again, that was by distributing the 2 to multiply the x as well as distributing the 2 to multiply the 2. So I have the value 2 times x, and I have 2 times 2 is how I would expand. And the final value then would be 2x plus 4.